Ok, bonsoir à tous, je m'appelle Greg. Je peux essayer de parler en français un petit peu, mais je pense que c'est plus facile comme tous si je parle anglais. Mais si vous voulez, en français ou en anglais, c'est un petit, mais peut-être petit peu. Ok, première, c'est competition, raffle. Prenez une photo de le QR code ici et entrez le raffle avec une licence pour UDB pour 1 an. C'est presque $8,000. C'est value. Et il y a trois licences à gagner. It is time travel debugger for Linux. So the C++ code on Linux, and you can. I will show pretty bit the time travel. It's really, really good. It pays for the pizza. Ok. Et j'ai présenté cette image à la fin aussi. Okay. Most programmers spend most of their time debugging. Okay, la programmation, c'est deux parts. Bugging and debugging. Okay? Typing the code in and then making it work. And the debugging, c'est 80%. But we don't talk about it very much. It's not a lot of talks, and this is my mission to talk to as many people in the world as I can about debugging. But this guy says it better. So this is Kernighan, Brian Kernighan, you know, the inventor of C and Unix. And he says, everyone knows, you might know this quote, it's quite famous. Everyone knows that debugging is twice as hard as writing a program in the first place. So if you're as clever as you can be when you write it, how will you ever debug it? Now, what Kernighan means here is keep it simple. Okay, give yourself margin for error. But I think there's an interesting conclusion to this, which is debuggability is like the limiting factor in how good our software can be. So whatever metric you have for good, how fast does it run, how small is it, how quickly can I write it, how well can people understand it, how extensible, whatever metrics you have, if it's twice as debuggable, you can make it twice as good. Like, you cannot be a great programmer without being great at debugging. So how do we debug? These are just some of the ways people debug. By the way, if anybody has any comments, any additions, just shout out. We're a small group. We can have a little bit of discussion, and that's even better. But here are some things I can think of for debugging, and we'll see some demos. I'll do some demos of some of these tools. Most of this, by the way, most of this is Linux centric. So if you're on Windows, then I'm sorry for you. But actually, a lot of it transfers to Windows or Mac or whatever. But so most of all the examples are going to be Linux. But yeah, we can use dynamic checkers. So Valgrind, AddressSanitizer. Who uses? Can I just see show of hands? Who uses Valgrind? Kind of, okay, lots of people. And AddressSanitizer or other sanitizers. Okay, so like a half maybe use Valgrind and a quarter use the sanitizers. Debugger, so if you're Java, it might be IntelliJ. If you're on C++, obviously GDB, maybe it's LLDB. So who uses GDB? Okay, most people. Okay, I just want to do a test. Who's used GDB in the last month? In the last week? Today? Okay, so all right, so we've got a bit of a mix. So I think this is my experience. Some people use GDB a lot, some people less often. Most people use it at least sometimes. I think for a lot of people, using the debugger, they kind of see it as like parallel parking. You know, parallel parking in the car where you have to, on the street, you only do it when you have to, right? There's dynamic logging, so you can add logs dynamically. There are tools that let you do this. Light Run, GDB has some capability for this. You just run git bisect, or whatever your version control system is, right? Find the faulty commit. That's a useful way to debug, or just think really hard. Like often, how many times have, I've been working on a problem, I've spent all day trying to solve it, eventually give up, and then 5 minutes later, when I'm not doing it anymore, the answer presents itself. So sometimes think hard or stop thinking about the problem. So these are all different ways we can debug, but you know what everyone does? Printf all the time, right? This is like 90% of debugging. And I think this is interesting. I think there are good reasons and there are bad reasons why we use printf. So this is first the bad reason. You may recognize this cartoon. This was quite famous, I don't know, 5 years ago or something, XKCD. Programmers are slacking off because their code's compiling. Well, why is it compiling? Probably because I added a printf, right? That's what most... So I think there is a laziness to programmers. I don't have to think too hard. It's kind of the programmer's equivalent of reading email. I pretend I'm busy, I feel good about it, but actually it's non-thinking work. Just add a printf, rerun. Oh, I need another one. Add another printf, rerun. Add another printf, rerun. So I think there's just a laziness and a kind of familiarity. It's kind of comfortable, but very inefficient often. Very inefficient, because you always think, programmers are always optimistic. You have to be a programmer, right? And so you think, one more printf, just one more printf. And usually it's all day. So that's the bad reason. I'm going to come back. But there's also good reasons. So printf gives us, I'm saying printf, it might be whatever you're logging, whatever logging library you're using, or whether you're using cout or whatever. But print style debugging gives us like a story of what the programmer's done, right? It gives us that history. And it's actually, I think, often the big problem with debuggers, and I'll come into time travel later, but the big problem with debuggers is they don't tell you what the program did, they tell you what it's doing right now. And print statements tell me what it did, and that's usually what I want to know. So there's good things about printf, but I think very often there are other tools that we can use that will be more productive. I think people use printf on the whole way more than they should. So I'm going to split today's talk into 2 parts. So just some advice and things that I've learned. And this is always interactive. So what I like is every time I do a talk, I learn something. I want to get something from the audience, and then that goes into the talk and I can talk about it next time, right? And then we'll talk about some of the tools that are available, and I'll show you how to use them. I think people have used some of these tools before, but a lot of people hadn't, and we can talk about the trade-offs. But we're C++ programmers, so we can't start counting at 0. So let's start at the beginning, and let's just define what we mean by debugging, and why is it so hard? I think debugging is, so when I say debugging, by the way, I'm not talking about only when something comes in from production, or even a test fails in CI. It's this thing of you type the code in and it doesn't do what you want. I like to think of myself as an okay programmer, and if I think how many lines of code can I write and it works first time? 10, maybe, right? How many lines of code? It depends what the code is, of course, but if it's real code, right, real application code, yeah, not even. And how many lines of code can I change in an existing code base and have it work first time? I think that averages to less than 1, right? I think most changes don't work first time, because if you're working on a complex code base with millions of lines of code, you change something you didn't expect. So I write the code and I have a set of expectations. This is what I think my program is going to do, and I run the program and reality diverges from those expectations. And the process of debugging is finding where does this happen, right? What is this point of divergence? And this can be easy, or sometimes it's easy, often it's hard, often it does something more like this. And So often the computer's doing billions of things every second, and we're looking for that one bad line of code, right? So there might be millions of lines of code, and it's probably doing billions of things every second. So it's a real needle in a haystack problem. And the way that we debug is by gathering clues, right? Like one at a time. We run the program, we get a new clue, and it's like this jigsaw puzzle. Every time we run the program, a new printf, a new clue of what's going in, and we fill in the jigsaw puzzle. It's kind of a strange jigsaw puzzle because eventually we get the last piece. We don't know when the last piece is going to come. So jigsaw puzzles are a perfect metaphor. Or maybe it's more like a detective story. Okay, I'm trying to find the clues. Basically, I'm running the program, I'm getting clues, and I'm piecing together information until I can figure out where does reality diverge from my expectations. And I've said here what makes, actually, I'm going to read, that's wrong. I keep making this mistake. What makes bugs hard to find? Because usually it's not fixing the bugs that's hard. Sometimes it is. Sometimes you realize, oh my God, I'm going to have to change. I'm just going to take this off because I'm too hot. Sometimes you find the bug and you think, oh no, oh my God, I'm going to have to change thousands of function calls or thousands of lines. But usually when you find the bug, it's easy to fix. We had one a few years ago, I think my most extreme. We spent months looking for this bug, months. And it was one character. It was a kill, to send a signal from one process to the other. And it should have been tkill to send it to a particular thread. And kill almost always does the same thing as tkill, except very occasionally it does a different thing. So I think that was the most extreme, many months to have a one character change. But often it's a one line, often it's removing a line, right? So it's finding the bugs is usually the hard thing. And what makes bugs hard to find? Well, I think there's two things that make bugs hard to find. The first is how long elapses between the bug itself and you noticing. Right, the program crashes. I think I know what's doing this. Hang on a second. It's WhatsApp, I think. Yeah. So I've got this on Do Not Disturb, I'm sure, but I'm on a stupid. You know what? Right, close that down. I think that hopefully was it. Right. Yeah, WhatsApp doesn't want to be ignored. Right, yeah, so the time between the bug itself and you noticing. So the bad line of code executes, and then sometime later, the program crashes. Maybe it's really easy, and I didn't check a pointer for null, and I dereference the pointer, and I get a segfault. And then, it's at that line. There's no time between the bug and me noticing. But maybe loads happens. Maybe it's seconds or minutes. And this is why wrong results is always the worst kind of bug, right? The program ran to completion, nothing crashed, no assertion failed, but it gave the wrong answer. Those are horrible because it could be anywhere in the billions and billions and billions of lines that ran. So the longer between the bug and the failure, the harder it is to find. And by the way, this is why assertions are so useful, right? Because what assertions do is narrow that window. They mean I noticed the bug much sooner than otherwise I would have. So I'm a big fan of assertions, and I definitely think in almost all circumstances, well, most circumstances, assertions should be enabled in production. That's my hot take for today. Anyway, so the time between the bug and it happening, and then the other thing is how deterministic is it, right? Every time I run the program, does it crash in the same way? Because if it does, it's not so bad. I can just keep adding printfs and I can keep running, and every time I get a new piece of the jigsaw puzzle and I put together the clues. But sometimes we have these bugs where every time I run the program, it does something different. Maybe it only fails one time in a million, or maybe it fails like the same number of times every time, but every time it takes a different path. And then every time I run the program and get a new clue, I get a new jigsaw puzzle piece for a different puzzle, for a different jigsaw, right? And the world is moving underneath my feet. So that gets really hard. And of course, life gets really, really hard when we're here. But no, I didn't stop WhatsApp, whatever. I know what's doing it. Maybe I can just silence that group. Like, I've been meaning to do this for ages anyway. So, mute. Right, there we go. Yeah, that's a weight off my mind. Right. I wonder if that will work. Anyway, yeah, so we're in the top right-hand of the corner, top right-hand corner here. So bugs are sometimes a long time between the bug and the failure, and it happens a different way every time. And these are horrible. These are the ones that take months, years, sometimes they never get fixed. One of our customers recently fixed something that this is a production bug in a very well-used database, enterprise class database used across the world, and it took them 10 years to find the bug. Not to fix it was easy, but eventually they found it. They used our stuff to do it. But and often actually they just don't get fixed. One of the things in talking to all of our customers, I find I'm surprised at how often, yeah, like big serious enterprise software on which the world runs, right? On which runs the internet, or it runs, finance, and often the engineers just can't fix the difficult bugs. And the response to be, well, the bug report might be, if I enable this option and this configuration together, it crashes in some mysterious way. And the answer often is, well, we'll just disable those options being in on the same time, right? That's fixed it. Because it's just too hard, right? Bugs are often just too hard to fix, especially when they're in the right-hand corner. It gets really fun when we get the Heisenbugs, right? So this is a reference to the Heisenberg principle. So we add a print statement or whatever, and the bug goes away or changes. The mere act of trying to measure it changes it. These are particularly horrible. All right, lots of different kinds of bugs. This is a bit of audience participation. And so I think, well, logic bugs, I mean, you could say every bug is a logic bug, but I mean, like, there should be a less than and there's a less than equals or something. Pointer errors, error handling is a common one. This is another of my hot takes. The majority of error handling code in the world is wrong, is buggy, and it never gets tested. It's too hard to test the error handling case, but we all got taught, hey, you got to handle errors, right? If the file system returns an error, I should handle that. Well, okay, I say, if you have a test case for it. And often people say, well, it's very difficult to add a test case because I need to do fault injection and, I'm just going to return the error, or, the exception will unwind and everything will be fine. You know what? It's not. If you've not tested it, it doesn't work. And if by some miracle it works today, it won't work next week, next year, right? Somebody will change something at one of the call sites further up and the error handling is broken. So all error handling is wrong and we shouldn't do it. We should just panic. If the file system returns an error, and you panic there, right? And unless you can't, if you really can't panic and you need to handle it, you have to have a test case. Race conditions are always in the top right-hand corner, right? Kind of by definition, race conditions are non-deterministic. They don't happen every time. And they tend to be a long time between the actual bug and you noticing. Some piece of state gets corrupted and then sometime late. So they're always awful. There was a talk about, we discussed undefined behavior earlier. I mean, some undefined behavior I understand why it's there. Most of it, I just don't understand why it's even a thing. It seems very strange to me. I think half of it is so that C++ and C programmers can feel intelligent. Anyway, it's there, so we have to deal with it. Bad interface assumptions, floating point problems, language weirdness. And that's kind of undefined behavior in a way, hardware weirdness. What else? What am I missing? What are the other sort of big categories of bugs that cause you misery, that hurt your life? Sorry?
Unclear specification.
Yes. So right, yeah, absolutely. Yeah, unclear or buggy specification. Yeah. What else? You'll notice I always get other people to write my slides.
Data-driven application where data change.
where the data, you mean the data changes?
The code stays the same, but the data changes.
Yeah, yeah.
The logic changes.
So data change. Do you mean like the data format changes, or the schema changes, or?
The content of the format you make a nice system complex that
Yeah.
follow a lot of cases, and someone use some magic value.
Yes. Yeah.
Too much items.
Yeah. Yeah. Absolutely. That's a good. Yeah. Yeah.
Bugs we consider as feature. Depending on who.
It's not a bug. It's a feature. Yeah. Okay. Any more? OS change. Yeah. Yeah, like OS updates. Like it worked fine, and then I upgraded the OS, and now, yeah. OS or environment changes. Yeah. Yeah. So I'm going to run out of space. Need a new slide. Any more?
We had a problem once where in a string we thought it was a space, but it was a different character that had.
Oh, right. Yeah, so like non-ASCII.
We couldn't find.
Oh, yeah. 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 I like that one.
Encoding in general is the possible.
Yes.
Or lack of encoding.
Yeah, let's just say like bad encoding. It reminds me, your space one reminds me of once we had a bug, this is many years ago, where we added a comment to the code and it caused a problem. It caused the code to fail. No, it's proper comment, properly formatted comment. There was, this is a long time ago, but there was a hash __ line directive, a line, __ line __ macro that would expand to a line number. And that went over from 256 to 255 to the line number was now more than 1 byte long, and that didn't fit where it was stored. So you can find, yeah. So I guess the summary is programming is really, really hard. And when it's not really a very human thing to do. The level of precision you need is too much. The amount of code we have is too much. The complexity is too much. Okay, so so let's go on to some general advice, right? So the point of debugging almost always is the impossible happened, right? This happened. Oh, that can't possibly have happened. It's impossible, except it did happen, right? I think part of this is almost very often it's bad assumptions. When I was writing the code, I assumed something, and I like this saying, an assumption is something you don't know you've made. So finding your own bad assumption is often the hardest thing. It's sometimes harder to debug your own code than debug someone else's code, right? Because you're blind to the bad assumption that you've made. So this is where rubber duck debugging comes in, right? Most people probably know this story, that you explain the bug to a rubber duck or another inanimate object. It comes from, I believe, there was a university professor teaching students programming, and he got tired of, they kept saying, Professor, I've stuck, I've been working on this all afternoon, I cannot figure out what's wrong. Okay, explain it. Well, the problem is I've got this, and then this happens, and that, oh, now I understand, right? And the process of explaining it to somebody, so then he put a rubber duck in the classroom and said, explain it to the duck, and if you still don't have the answer, then you come and talk to me. I find a good equivalent of that is to write it down. If you don't have a duck, write down what you're seeing, but with pen and paper, because two reasons for this. One, when you write with pen and paper, it's slower, right? We all type really fast. We can all type much more quickly than we can write, so you're not really thinking about what you say. And the other thing is there's studies that show it just it affects the mind differently. It affects the human brain differently when we're writing versus when we're typing. So physically writing it down, it does sometimes end up a bit like that, but often you just write down the same thing with rubber duck debugging. What I'm seeing is absolutely impossible. There's no way because I checked for foo and I know that bar is not 0 and oh, actually do I? The next piece of advice is when you smell smoke, you act. If you were in your house or in this office and somebody smelt smoke right now, we'd go and find the fire, right? You wouldn't go, it's probably someone else's fire, probably not my stuff on fire. It'll be all right. Yeah, right, I'm busy. Now, I understand sometimes, like, this is not practical. Sometimes, you know, that you have a deadline and you can't track down everything. But I think by default, you want to keep going until you find the root cause. And so very often people go, oh, well, you know, this pointer is null and we dereferenced it and there was a seg fault. It shouldn't ever be null, but whatever. I'll just, if pointer is not null, then I'll dereference it. Problem goes away, test passes, I haven't fixed it. And I find often, this is my experience, when I see something that's not right, I reckon at least 50% of the time, at least half the time, I see something that's not right. And I think, well, that's not right, but it's not the bug I'm looking for. So maybe I'll like put an entry for it in a GitHub issue or put something in Jira or write it down, or so that then, you know, everyone can ignore it. But that's not what I'm looking for. I'm busy. And at least half the time, actually, it turns out that is related to the bug that I'm looking for. It's just I hadn't seen the causal effect. So maybe it depends on what kind of quality the code base you're working on is. Sometimes you can't go anywhere without discovering a bug that is unrelated. But follow that down. And because apart from anything else, we all pretty much work in teams, right? Well, even if it's a team in one, so you've done a load of work to get to this point, to find this thing that's wrong. If you ignore it, then your colleague next week, next month, next year is going to find that bug, and they have to go right back to the beginning. They have no information. They'll need to redo all that work you did. Yeah, and that's likely to be you. So I know it's stressful. We're under pressure to fix things. We feel like there's loads and loads of bugs. But if you do a kind of depth-first search, I find in the end, you win. In the end, it's more productive. Lots and lots of assertions. We already spoke about this. Okay, make the time from failure to noticing shorter. I have another rule of thumb that about 50% of assertions that detonate are just bad assertions, right? They're not actually, it turns out that this can be null while that is 0 or whatever. But that helps you understand. Adding all those assertions that then fire helps you understand like the invariance of the code that I'm working on. So you just can't have too many assertions. And yeah, I changed my mind on this about, I don't know, 5 years ago. I used to feel assertions should not be, they certainly shouldn't be fatal in production because 50% of assertion failures are just bad assertions. But I changed my mind. I think actually you want, because if it's not fatal in production, we used to make most of our assertions used to be by default not fatal. It would print a warning and then carry on. And the thinking was, oh, well, customers will tell us. If customers ever see this warning, they'll let us know and then we can investigate it. That doesn't happen, right? People just care. If it's a warning, we see warnings all the time. People ignore warnings. So you make it fatal and then you find out what you need to know and you will, in the end, your code will be better. I already talked about this. Yeah. So if you don't have a test case for an error path, just hard panic, abort, assert fail, whatever you want to call it, right? And then the last piece, kind of a meta piece of advice, is use the tools. There are lots of tools. Okay, too many probably to learn every single one, but there are lots of mainstream tools that are really useful, and the more we use them, the more productive we will be. And most of them are really good. Right, and actually well thought through and programmer friendly because they're all pretty much all written by programmers for programmers, right? And I'm just, the sanitizers and Valgrind and, all these things, usually the documentation's pretty good. It's not perfect. Same goes for GDB and LLDB. Documentation's pretty good. The user experience is pretty good. You can get up and running quickly. They are software. Software tools are themselves software, so they are not perfect. But mostly I think they're good, better than we realize. I remember when I first used Valgrind, and it took me, I don't know, well, probably 3, 4, 5, maybe years to have the courage to try it. I heard about this thing and it sounded like magic. And if it's that magic, it must be really hard to use and it must be kind of flaky. And it took until I was completely stuck, which I was looking at a memory corruption thing and I didn't even have the source code for it. And so I tried everything I could think of to avoid, I'd done all the printf I could imagine, I'd done everything I could to avoid using Valgrind. And eventually I thought, right, I'm going to have to do it. This is going to be hard. I'm going to have to think really hard. It's going to be unpleasant. It's going to take me days. I'm probably going to have to rebuild my code. Probably going to find there's missing libraries that I need to install, and then there'll be incompatibilities. Most of you have used Valgrind. It just works, right? It just did. I can't remember what distro, but sudo apt install Valgrind program. Ta-da! I was like, wow, why did that take me so long? Very often these things just work, and you just can't believe you spent so long to engage with it. And then once you've got that knowledge, now you know it forever. So while I'm doing the talk today, what I do in most of my talks is not to try to make, they're not tutorials. No one will leave this talk or any of my talks being an expert in any of the tools, but you will just kind of know they're there. And then when you need them, you'll kind of know what to look for, right? You'll know what documentation to look up. So there are so many tools. We talked a bunch about some of these. I'm going to try and get through as many of these as we can. We have until, I think, 8:30, right? So, I mean, I could probably go to midnight if we want, but I think probably there's some pizza coming. So let's start. This is a talk on debugging, so let's start with everyone's favorite. We even have some people who've used GDB today. Now, I think GDB is, it's like fractal in its richness. There's so much to it. I mean, it's been going since 1985 or something. So many features, and the features themselves have features that it's like I'm learning stuff about GDB all the time. I've kind of made a bit of a side career as like the GDB guy, and I still learn stuff about it. Every time I do one of these talks, someone teaches me something about it. So a lot of people think they know what it is. Well, it's break, next step, continue, print. That'll do. Run. But there's so much to it. So I like to do these kind of polls. So TUI mode, text user interface mode. Who's used that? Yeah, I see way few. So definitely
original.
No, right. Right, no. So it's okay. So this is one of the things so GDB I think is really good, but there are some things that are bad about it. And one of the things is the naming and the discoverability is terrible. So you would think that text user interface. So if I do this, and then I do that, that's a text user interface, right? It's all text. And I think this program doesn't. Let's do one with debug symbols. That's not really fair. So let's do GCC. By the way, -G3 is good because you get more debug info. So yeah, that look and like it can go. So that looks like that's not text. That's command line interface. Text user interface looks like that, right? And you can get into. There's a bunch of ways you can get. Probably the easiest way. That was Control-XA. The easiest way these days is just go TUI enable. I think this should be the default, right? I think that's another thing about GDB. I think they're a little bit. The maintainers are a little bit cautious. They want to maintain back. I think they should be prepared to break backwards. So they should make this the default. Anyway, so I think this is scores the best for the most useful and least understood and least used feature. We actually had a customer quite recently, and so we have one of the interfaces onto our product is our version of GDB, and we like to ask customers, what do you like about our product? And one of them said, oh, I love the TUI mode. And we're like, yeah, you do know that you can just do that in GDB. That's not, we don't provide you that. You can do more than just like, I don't have many pixels here, but let's see if we can, like, I can go Control X2, and now I can see the disassembly. So that's kind of useful. I can go Control X2 again, and now I get, yeah, I don't know, I get disassembly and the source. I've got this, I don't have many pixels. Let's make the command window, so I can go set win, what's it? Hang on a minute. I can make this smaller. Anyone remember what's the command to make TUI mode windows smaller? I thought it was win height. Maybe. Oh, it's not set. It's just win height, right? So win height, and I give it. This is the command window, and I'm going to make it 5. Oh, that made it bigger. I wanted to make it smaller. There we go. All right. So yeah, I haven't got a lot of pixels to play with here, but you can do like a lot of stuff with TUI mode. But to be honest, 90% of the value, if I go Control X2, keep going Control X2, it comes back here. One of the things everyone hates about TUI mode, again, this is why they should fix the defaults, is still a command. One of the nice things about TUI mode is it's still got the command line here, right? And that's actually another of what I don't like about most of the IDEs, VS Code, CLion, all these IDE clips. They take away the command line from you, right? Because it's kind of a philosophy that I should be using the IDE shortcuts and the map, and they're like, no, give me the command line. So TUI mode also gives me the command line, which is nice. But with command line debugging, we do a lot of, well, command line anything, up arrow, right, to get through the command history. I don't want to type everything out every time. And in TUI mode, when I do up arrow and down arrow, that happens, right? So, but that's like, okay, so we can go, because this is a GNU program, so the good GNU way is you can go Control P, because it's read line, Control P for previous. I can go through there, Control N, and I can go like Control B to go back, Control E to go to the end. All the kind of like bash will do the same, right? And any read line application will give you that. Or if I really want to use, the arrow keys, I can go Focus Command, and now I can use up arrow and down arrow to go left and right. So again, I don't know why, but TUI mode should be the default, and Focus Command should be the default, and I think GDB would like immediately get twice the usage that it has today. Maybe I will submit a patch and have them dismiss it. Right, yeah, okay, that's TUI mode. I think, anyone got anything to add? Favorite thing about TUI mode, or most annoying thing about TUI mode? Who uses TUI mode like by default?
You can't use it properly on a VT100 terminal.
On a VT100 terminal? Can you not? Does it not? It doesn't have enough, well, the VT100 doesn't have enough like control characters and stuff. Yeah. Is that your life? Do you spend time with, no, okay, all right. Yeah. It doesn't, no, that gets a bit, I think it's a bit better these days. I think the new...
They grab the mouse and they switch the terminal to the mouse.
Yeah.
Mouse mode, so you cannot copy paste.
You cannot, on the new ones, you cannot copy paste. Yes, right. So what you have to do, yeah, so if I try and copy paste, you can't see this, I'm holding down the left mouse key and it's not copying, but really annoying. You just press Shift and then you can do it.
Yeah, I know,
but no one knows this, right? Yeah.
There's no configuration to disable.
Yeah, right. So, yeah, I think it's a bug, to be fair. I think it's just a bug and, but no one, yeah, so hopefully that gets fixed, but that is annoying. But yeah, that's a top tip. From newer versions of GDB, hold down Shift and then you can select the text. Anything more on TUI mode, or shall we move on? Okay. Python integration. So this is really good. This has come on really nicely now. The Python integration into GDB. Who uses it? Who's typed Python at GDB? One. Oh wow, just one. Okay. Who knows about it? Is this like news? a little bit. So yeah, so it's got a Python interpreter in it. I'm going to get out of 2 mode now because that's yeah, so you can go like Python print hello, and it does that, right? And it also has, but there's a, actually I'm going to go back into 2 mode to show you something. So you can go, there's a GDB module. So I can go like, I can do pretty much anything that you can do through GDB. You can now do through the GDB Python, the GDB module. So I can make an instance of a breakpoint class. Let's put it on line 8, like that. Look, breakpoint appeared. And now I've got that object. So I can go like my BP dot, I think it's enable equals false. There you go. See that plus changed to a minus. So you can do anything. You can look at the data. You can set breakpoints, watch points. You can. It's got quite a rich API to dereference the program data. So you can like walk the data structures of the program. And yeah, like if you can think it, you can do it. And one of the nice things of the Python is the pretty printers. So only one person put their hand up for Python. So do you use the Python pretty printers? Have you written pretty printers?
No.
Okay, but you use them. They're people, yeah, as in the ones that come with the system or somebody in your company?
The ones by default.
Yeah, so the ones there by default are good. So we got, I think there's my, this is about as advanced C++ as I know how to write, by the way, but so I can like, so I've got this vector, and then we're going to push some things onto the vector, and now when I print the vector, it tells me useful things about the vector, right? It knows how to walk the STL structures. But it sounds like, okay, so does anybody work in a project or in a company where there are pretty printers for your internal data structures? Yeah. On a scale of like 1 to 10, how awesome is it that you have those? 10, right? You're less convinced. That's okay. We can disagree. I find, you know, again, it's a bit like Valgrind for me. When I first learned about Python pretty printers, I thought that sounds really useful, but it's going to be hard, and I'm busy. I want to get this bug fixed like now. So maybe one day in the future, I will learn how to write a pretty printer. And eventually, 2 years later, I finally decided, right, it's time. It's really straightforward. Like, okay, it's not as easy as I would like it to be. There's a bit of boilerplate. You have to copy paste an existing pretty printer, but it's not hard, right? And then future you will thank yourself. You will be so happy that you did that, and every time you try and debug something, it will be better, I think anyway. And then you find a world very quickly you can't live without it. So Python pretty printers are like, well, interesting. So you felt that like not so useful.
Yeah, because you need to have the same Python. You can use
You
a
do.
different Python for your executable environment that is the one that is currently used by GDB.
Right. Well, yes. For so this is for the STL pretty printers, right? Or for your yes, that's true. So that's a catch. Yeah, that's a gotcha. So Python is the GDB has a copy of the Python interpreter in it. If you're using GDB on Fedora 39, then it'll have the same Python interpreter that's on Fedora 39. And so everything works fine. And on Fedora 39, there will be the nice thing is with it's half good and half bad, right? It's 3/4 good. So I think so because I'm running on, if my program is running on one system, usually I'm compiled on one system and I run on another, like not always, but usually. And when I'm debugging it, I need to look at the pretty printers for the STL on the system on which it's running, not the system on which it was compiled, and not the system that my GDB comes from, right? So It's quite good. So most Linux distributions ship with Python pretty printers for the STL that's there on that machine. So it just works. It's great. So it doesn't matter where you compile it. Doesn't matter where GDB was compiled. It will look at the STL pretty printers for the machine on which you're currently running, and like if you're shipping a core file across, it probably won't work. But if you're debugging a live process, you get what you want. Except if you've compiled your GDB on a different system, therefore now it has a different GDB interpreter built into it, and then that you bring it over here, and now it tries to load the Python libraries modules for those pretty printers, and you get version mismatch. And unless this has changed recently, Python doesn't tell you about this. GDB doesn't tell you about this. It just doesn't work in various levels of, like, sometimes it totally doesn't work, sometimes it works a bit and not others. It's very confusing. So yeah, just be wary. The advice is use the GDB from the distro on which you are running. Don't just, used to be at pre-version 7, pre-Python, you used to be able to copy GDB as a standalone binary and it would just work wherever. Now, like, it still will, except for things like these Python pretty printers. I know sometimes we work places where you have your own like custom GDB build, and this is probably, yeah, so I know it can be tricky. So yeah, like everything, it's not perfect, but when pretty printers work, they are great. Yes.
One question, what you can do with command line GDB, we can do with the interface?
With the TUI interface, or?
GDB is often integrated in
Oh yeah, like a VS Code or whatever. Yeah. I mean, one of the good things is scripting is one. Adding Python pretty printers is another. Well, I don't think, maybe, I mean, I might be wrong on this, but let's say I'm using VS Code. How do I source my pretty printers? Like, it better be in my GDB init, I think. Otherwise, I can't source the pretty printers or source other Python into, I think. Maybe I'm wrong. Maybe I just don't know how. Yeah.
Also conditional breakpoints.
Oh, really? You can't do...
Yeah, you can do it
In which one?
VS Code.
In VS Code?
Yeah.
Okay.
And
Yeah.
also about pretty printers, in VS Code you can also print your containers as they are, in memory.
It does, yeah.
And,
That's really nice. Yeah.
It's perfect.
Yeah. No, it's really nice. That does work very well. I just wish there was a command line there so that when I want, and also I'm more of just a command line person, so I'm just a bit, and I know, my muscle memory knows all the GDB commands. But we've got things like, yeah, I bet you can't do dynamic printf from VS Code. You can do log points, which maybe they're kind of the same. Maybe that's not a good example. I tell you what, right. So GDB is very bad at discoverability, except for it does have the tab complete. So there we go. Right. Can we do all of these? Oh, can you have catch points? Does VS Code do catch points? Probably not. Can I do set symbol file? Can I do advance? Can I do dprintf? We talked about that. Can I do pipe? Can I, like, I bet 90% of it. I mean, that's just like, there's just so much of it, right? Yeah, what's the one? What's the thing where you change the path mapping? Set substitute path. But you can't do that from VS Code. Can you do T-break? Can you decide what threads to look at? Can you set the stepping, set scheduler stepping, the set scheduler mode where you can step just one thread or all of the threads at a time? But you can't do that from VS Code. There's loads that you can't do, and I just like the command line. Anyway, this is probably more of a me problem than anything else. So the Python integration is really good. If you can imagine it, you can do it. And if you haven't written a Python pretty printer yet, I urge you to do so, and you can thank me later. Obviously, everyone knows this. I think you can load up core files. You can attach to a running program. You can do remote debugging. Okay, so I can have GDB here and the thing I'm debugging on the network or even over a serial line somewhere else. There's a thing called GDB dashboard, which is quite nice, which is like an alternative TUI mode. It's just a GDB init file. So I think I've got it here. It's GDB dashboard. Just comes with a GDB init, which I source. And now I don't have enough pixels on this screen, but you just get more stuff. So it's like TUI mode, but different or better. Some people like it. Yeah, dynamic printf's good. So I said that there is an advantage to printf debugging, which is it gives you a story of what's happened. And that, sometimes the debugger is a bit like a microscope on the problem. And I want to kind of have a higher level view. Dprintf lets me but the problem with printf debugging, of course, is I need to recompile. And that's really, maybe I can recompile quickly, but sometimes recompiling is a big job. And we can do that with, I can't remember how to turn dashboard off. So we'll just quit out and come back again. So if I go, now again, the syntax is awful, but let's do it at line 8. So I'm going to go dprintf. I give it a just any breakpoint style thing, and then I give it a string. So vector, and I can do like this. I don't know if that works, but that probably will. Does that work? No. Okay. I have to go. It's a bit crummy, but it is quite. It's like a lot of GDB. It's crap, but cool. So now I've got this dprintf, so it's going to print out that. And so when I continue, I didn't put new line, but you can see what's happening. I'm going to do it again. And it's just like it happens just like a breakpoint as well. So info break. So looks there, so I can delete that breakpoint. Let's do it with the new line, just so we can see. Look, I've got my printfs without recompiling. There's another cool command, just while I think of it. It's a command called compile. Anyone use this? I've only used it once or twice. You can compile some C code and inject it into the running process and then execute it. Yeah, lots of front ends. So a lot of people like VS Code, C Line. A lot of people use Emacs, and that's perfectly legitimate IDE in my opinion. If you like that sort of thing. A lot of people still use DDD. Anyone use DDD? Anyone heard of DDD? It's really old. Yeah, it's like, it was cool when I got my first job. I think that's how old it is. And it does two things that no other GDB front end, to my knowledge, does. One, it has the CLI that I can type at. Actually, Emacs does as well, and so does our VS Code extension, but generally it has the CLI. And the other thing it does is it lets you draw data. It's called the data display debugger, and it lets you kind of draw your data structures and pointers and things, and you can visualize your data structures. And like no one maintains it. Well, there is a maintainer, but it's like totally unloved. Still works, and yeah, a lot of people like it. And I don't know, yeah, somebody should add that functionality into VS Code and C Line. Vim Spectre, if that's your thing. Okay. Oh yeah, all right. Okay, so some GDB myths. So I'm going to try and not talk just about GDB, but all right, GDB will change my code's execution. No, it won't. But I've seen this on the internet. There's a lot to read here. We're not going to read all of it, but just look at the bolded text. The system call may return prematurely. So instead, I would be able to say sleep 10. And if I'm debugging with GDB, you need to do this because just hitting breakpoints and things can cause system calls to return early. Not true. This hasn't. Well, it might be true on some certain operating systems, but it hasn't been true on Linux for years and years and years and years. But this is still out there on the internet. Actually, it's in the GDB documentation. So things, so there's only let's say you attach to a program, and and then you just continue. For the most part, that program will run like completely unhindered, except for two things. Okay, three things. Right, three things. If it receives a signal, GDB will stop. Now I can change that with GDB. I can say set signal and handler disposition to continue, but even so, it still goes back to GDB while GDB then decides to continue the program. So that will interrupt. That might slow it down a bit. It won't change the behavior, but it might slow, apart from possibly slowing it, well, it will slow it down, but otherwise it won't change it. Thread creation and destruction, GDB gets notified about those things when they happen, although you can turn it off. I can't remember how now, but there is a way to tell GDB don't trap thread creation destruction, so that will run at full speed. And then shared library loads. When the loader and linker dynamic shared library is loaded, it will hit an internal breakpoint, and that goes back to GDB. You don't see it, but so those things will slow down the execution. But if you're not creating and destroying threads, and you're not handling signals, and you're not loading and unloading dynamic libraries as you run, the program will run at full speed, completely unhindered, I assert. And it certainly won't change behavior. So this is nonsense, and it's very sad that it says it in the GDB documentation. Again, I should really submit a patch, but I'm too busy complaining. Debuggable code is slow. No. So this is kind of a similar point, really. So a lot of people have a binary choice. You can build debug or you can build release. And if you build debug, it's like -0 and lots of extra hashif and debug checks are in there, and the whole thing runs slow. I've got a customer right now who's struggling with, their debug builds are like 10 times slower. And I think it's because they add in all these checks. And they work in a big organization, giant American tech company, and they have no way. And I'm like, well, it's all right, you can just compile with -G and optimization and without your debug, and it will all work fine. Of course, they can't do that because they don't control the build environment. That's done by somebody else, and they don't have control. But so I now have a mission to go and educate that particular company's build people. But yeah, you can have as much optimization as you want and as much debug info as you want. Obviously, if I'm debugging optimized code in GDB, it is a difficult experience sometimes, and I'd go next and it goes back one line, and value optimized out, everyone's favorite error message. But the point is, -G does not change the code that's generated at all. It just adds these dwarf debug info sections that in normal operation, they don't even get loaded, right? They stay on disk. So the only time it might matter is if like you've got containers that are coming up or something and you care a lot about your disk size. And it does increase the link time in particular if I've got debug info, because the linker needs to go and patch loads of stuff up. But I can have split, I'm not going to get into it, but there's a thing called split dwarf, and you can and you can have the dwarf be in a separate file, and then there's no need, then everyone should just compile everything with -G, in my opinion. Even if with split dwarf, maybe you don't want to ship the debug info for commercial reasons, but you should have it locally. So when you have a core file, you can do something with it. This is my favorite one. Debuggers make programmers lazy. Anyone heard that? I've heard that a lot. And variants of it. What does it even mean? Do tractors make farmers lazy? Right. I mean, it's a productivity thing, so I don't understand that at all. And GDB doesn't work well with threads. Again, I hear this a lot, and I don't understand why people say it. Yes?
The previous bit, I a little bit agree, because a lot of developers are using debuggers rather than refactoring their code or making code clean.
Really? Like that's okay. That's bad. They shouldn't.
Like that with ugly code, they just use debugger to understand their code.
Oh, so they should so rather than refactor, they use the debugger to understand it. That's not the debugger's fault, though. right? That's the programmer's fault. Like I agree, that's a bad behavior. But if you take the debugger away, do you think they'll refactor the code? I don't think they'll I think they'll just use printf, they'll fix the bug and they'll move on, and it's like, not my problem. So I don't agree with that. In fact, I'd say the opposite. I think debuggers, especially true if you've got time travel, will allow, they make it easier to root cause what's going on. Okay, that value is null. It shouldn't be null. Why is it null? Let me get to the proper root cause fix. If the debugger can help you to do that. So it's a bit, I think, yeah. Maybe it can cause some behavior. I think the most famous proponent of this comes back to the introduction, actually, with Linus Torvalds, right? I think he for a long time was opposed to debugger, the GDB stubs being built into the Linux kernel. You had to make your own Linux kernel because he felt debuggers were a bad thing. I think, and his view was more like, you should understand, like you should just know the code. You should know every line of code. And if you're Linus or fortunate enough to like have your own project that you've started from scratch and you know all the code, well done, lucky you. But most of us, that's not the case. Most of us work at companies where there are millions of lines of code that most of them are written by people who don't even work there anymore. And so we can't possibly, like, what are you going to do? You get a bug report, you're going to read 10 million lines of code to try and understand where the bug might be. And I note that I submit that it is not a coincidence that Linus did change his mind and he did allow the GDB server stuff to get into the Linux mainline at about the same time when Linux got big enough that no human being, even Linus, could understand the whole thing. So that's my personal theory on that. This usually gets a bit, yeah, so GDB doesn't work well with threads. Hear that a lot. Can anyone believe that, and can they explain to me why? Because I don't understand it.
Maybe because the stack, to navigate through the different stack frames
Yeah.
in the debugger might be a bit tricky because you need to make T1, T2, T3,
Yeah.
Blah blah blah.
Yeah.
And it may be it. I don't know.
Yeah.
I don't think that's either. But,
Yeah. Right.
Laziness issue, no?
I think.
It looks like a bit more complicated, so I will go back to printf.
Yeah. 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 Right. And of course, Heisenbugs, right? Printf is fantastic for making race conditions disappear, partly because it's slow. It's going to issue a system call, and also, we'll see this if we get time. That we're not going to get time, but the libc printf will take a lock internally, so it becomes a sort of synchronization point. So, yeah, like debugging race conditions is really hard, and debugging threads is hard. And I don't understand why people say this. I think it might be partly because it used to be the case in early Linux and early GDB, like 15 years ago maybe, it was a bit ropey, and GDB would cause multi-threaded programs to behave a bit differently. That is no longer true, and hasn't been true for a long time. So I don't understand that statement. And then lastly, yeah, GDB has difficult UI. I don't think it's true. I think it's actually mostly pretty well thought through, pretty consistent. There are exceptions. We saw me struggling with setting the window height, earlier, and dprintf, that's ugly and just weird. But those are the exceptions. And most part, the interface, once you understand what the interface is trying to do and the structure of it, it actually makes sense, and it's coherent, and it's well documented, except for when it's not. But it's software, right? All software is difficult. And yeah, anyone used Git? I mean, I think GDB UI is much maligned. Was I thought a hand go up. No, oh, that was a yes. I've used Git. Yeah. So like it's not that bad. It's no worse than anything else, in my opinion. Right. We said we stop at 8:30. I can go and do my favorite demo and show a bit of time travel, and then we can stop, or we can keep going. Is pizza coming? It's coming. Yeah. Anyone? We only got a few minutes. Maybe can we go over by 5 minutes? Is that okay? Anyone hoping to see something that they covered? Yes. I can't go. You want to see LLDB? Yeah. Okay. All right. So LLDB, and then I'm going to show one more thing after this. I'll try that. Right. So LLDB is like GDB, but worse and better. There's a lot of rumors around that LLDB is works better with C++, complicated C++ debug info parsing. It's really hard to know, right? There's no metric, no one. So yeah, I think sometimes it works better, sometimes it works worse. It just depends on your code. I can do a whole rant about the quality of debug info and how compiler writers don't consider it to be a bug when the debug info is wrong, and I think that's really bad. But it has a GUI mode, which is just like TUI mode, except I'm sad to say. Anyway, so look, if it's LLDB a.out. So it does this. I don't know why it says that, but it doesn't seem to be a problem. So I can put a breakpoint on main, just like with GDB. I mean, it's a little bit different, but kind of the same, right? I can run the program. It runs to main. It shows me a bit more information. I can go GUI, I think it is, and that gives me LLDB's version of TUI mode. I don't like it because it doesn't have a CLI, but it's basically the same. It's got Python integration. It's got Python pretty printers. It's mostly compatible, I think. And it's just a competing offering. I think in general, it's not as well maintained. Like the number of hours that have gone into GDB is, I suspect, 5 times or something more than has gone into LLDB development. So there's a lot of features that just aren't there, and the features that are there are a bit kind of, so there's a lot you can't do in this GUI mode. But some people find it works better for them, particularly for complex C++ with templates and all the rest of it. So kind of you have to try it, but it's basically the same but different. Unless anyone wants to.
The only thing you have on macOS, no?
Right, if you're on macOS, that's what you have. Yeah, I mean, I think you can run GDB on macOS, but no one does. Yeah. Yeah, you probably should just, if you're on macOS, you should use LLDB because that's just going to work better. Yeah, yeah. But this talk does have Linux in the title. So.
Does it work better if you have a long LLVM toolchain for compiling?
So, yeah, I've heard people say this, and it may be true. I haven't verified it. I've asked them, and for like evidence, not because I don't believe it. I'm just interested to know. Okay, so like, in what ways is it better? Nobody's been able to tell me why. So, in theory, it's better. Some people say in practice it's better. Maybe it is. I don't know. Generally, GDB works pretty well with Clang, in my experience, but so I think it just both, neither debugger is perfect, and on some code bases LLDB works better, and on some code bases GDB works better. Some people find GDB very slow with very big programs, and they find LLDB to be okay. Actually, I think later versions, that might be a GDB version thing, but again, I think it just depends on the program. I want to show very, very quickly something that isn't GDB because, I just feel that I should. So everyone said, right, so here is a little program which, actually, let's just do the first version of it, which allocates 10 bytes on the heap and then writes into the 11th byte of the allocated memory. And if I run it, well, nothing happens because you've kind of got away with it, but obviously that is bad. And if I run it in Valgrind, well, it tells me there's a leak, first of all, because I never freed that data. But more importantly, it tells me that there was this invalid write of size 1, and it should tell me the line number where that happened.
At the bottom.
Oh yeah, right. I'm pointing at it without seeing it. Oh yeah, so that's really useful, right? Way easier to debug. It goes very slowly. There's a whole bunch of different tools as well. So Valgrind, that's actually called memcheck. Tab. There's lots. So Helgrind for race conditions. That's I've not used it in anger personally myself, but I've heard people report good things about it. And then there's AddressSanitizer. So more people said they'd use Valgrind than AddressSanitizer. So, I just quickly, actually, sorry, before I do that, let's do this. So this is like the same, except it's on a stack. I've had to put some padding to, I can't remember why, I had to put some padding, but same thing on the stack. Oh yeah, it would the program would fail. So let's do that. So run it with Valgrind. So the default tool is memcheck. But that's the default. I don't have to say that. No errors detected, because Valgrind doesn't know. Right? Valgrind intercepts your malloc calls and it knows where the malloc objects are, but it doesn't know where the compiler knows, but Valgrind doesn't. I think it could actually. I think it could use the dwarf information to figure it out, but it doesn't. If I do the same with AddressSanitizer, now it does know. So AddressSanitizer is like Valgrind, but it's basically a compiler feature. It compiles the checks into the resulting binary, which means it runs much faster, and it knows some things that Valgrind doesn't know. So now look, it's like, yeah, it's figured all that out for me. So AddressSanitizer is better, except I have to recompile, and maybe I can, maybe I can't. Maybe I work at a company where that is not so easy. Maybe I don't have the source code. If I do, then AddressSanitizer is pretty good. So that's Valgrind. It's very slow, like 100x, 1000x slow down sometimes, but still can save you a lot of time. Yeah, sanitizers. There's actually loads of sanitizers. AddressSanitizer, ThreadSanitizer looks for race conditions. MemorySanitizer for, I can't remember. What does MemorySanitizer do? Is it like misaligned writes or something? Yeah, or in Clang. Anyway, it does a thing. Much faster, knows more stuff, but you have to recompile. There's loads of sanitizers. I got this list by going tab. So -f sanitize equals tab. There's this one undefined, which is really useful. Undefined behavior sanitizer. And actually there's no all option because some of these are mutually exclusive, but undefined will do all of these checks. So sanitize equals undefined is a good thing to do. I recommend everybody run as much of their tests as they can under that mode, at least like sometimes, right? Okay, that sanitizes. I want to do one last thing and then we'll stop. This is my favorite demo. I need to sit. And I have a program here which, well, I'll show you the source. So it's a bubble sort, and like it's just a very, very naive implementation of bubble sort, and it gets an array and it gets random data in the array and it sorts it. And if I run it like that, it works. Except I happen to know if I run this enough times, eventually it crashes. Segfault. Okay, let's have a look at the chord file. So there it is. Let's load that up into GDB and let's get a backtrace. Who's been there? We've all been there. So I don't know, stack corruption probably. So let's use time travel debugging. Now GDB has inbuilt time travel debugging. So the problem, if you remember I said about debuggers, is they don't tell you what happened. They tell you what's happening, and usually what you want to know is what happened. And this is where time travel debuggers, of which there are several, we make a really, really good one, but there are others. And it's a game changer, in my opinion, with debuggers. There's time travel debugging built into GDB. It's very slow and it doesn't work very well, but it does make for a good demo. If you want to use open source time travel debugging on Linux, RR is your friend. And if you want to, if you can't use RR for some reason, or you want the advantages that we have, then enter the raffle and you can have at least UDB for free, or you can pay us lots of money. So let's run, but I like this demo because it shows multiple features of GDB. So every time, so this fails like whatever, 1 in 100 runs or something. So I'm going to put a breakpoint on main, and I'm going to add some commands to that breakpoint. So every time the breakpoint main is hit, the following commands will be run. Turn on recording and continue. And I'm going to put a breakpoint on exit, because remember the program died with a seg fault. It never got to exit. So if I get to exit, I want to put some commands on there. I'm just going to rerun the program, start again, because obviously the bug didn't bite in that case. And now I do know to go set pagination off, because that's just always annoying, and set confirm off, because yeah, I do want to restart the program. And now go. So this is going to go around and it hits main. It enables recording, which is an instruction level recording. And we'll see exactly what that means as soon as this program crashes, which it definitely will soon. Yeah.
The instruction recording is done like using software, like doing in3 by hand. But I think they support also the Intel.
Right, there is the Intel processor trace, which is super fast, like almost not a measurable slowdown, like 3% or something, or even less. But it doesn't give you data. So it's just program flow. But it's very useful, yeah. So you can go record btrace like that. But yeah, no data. And data is a really important part. So my opinion, actually Intel say the same. If it doesn't have data, it's not really time travel. So program stopped. It didn't say segv because there's a bug, but it stopped with the segv. So actually, I can probably, I haven't tried this. No, all right, doesn't matter. It stopped. And just like before, I have a corrupted stack. And so what am I going to do? Well, I've got time travel. So time travel gives you reverse commands. So reverse step I, steps one instruction. Reverse step I is going to go back one instruction. So I can see immediately what happened before. And oh, look at that. We appear to be, let's get that view at a return instruction. This is x86. This is just running on my laptop. So on x86, it's a fully descending stack. So that means that what is at the stack, so what's on the top of the stack, so if I go like that, that's what it will return to. And that doesn't look very much like a pointer. X to examine the memory. Indeed. Right, so I've got garbage at the top of my stack. I need to know, how did that happen? Somebody's written garbage into the top of my stack. This is a very small program, but in a big program, that's often a horrible thing to debug. What I want is a watch point. Actually, there's also another bug, so just ignore this. Hopefully this gets fixed. But anyway, so what I want is a watch point. I'm going to use a location watch point for reasons. And I'm going to watch, that's top of the stack. So anyone used a watch point in GDB before? You run until the data changes, right? Sometimes Microsoft call it a data breakpoint. Very useful in niche scenarios. With time travel debugging, it's like a superpower, because I set that watch point and now I go reverse continue, and it's going to run back until the watch point triggers. So that's going to say what line of code updated the top of my stack, if this works. Ready? Cross your fingers. Yes, I got it right. So, oh yeah, well, it's probably not that surprising, right? I'm writing into an array and print I, and what is array? It's 32 entries long, and I've got this stupid size of, it's, percent bytes, not elements in the array. But I like that demo because it shows time travel. It shows using commands off breakpoints, which again, don't think you can do in Visual Studio Code. Maybe you can, don't know. and just generally kind of a bit more creative way than just print and break and next and step. That just leaves me to get to, so yes, it's very slow. Anyone who's used RR? A little bit. Didn't change your life? Did it work for you?
No.
It didn't work. Or it worked but didn't change your life? Yeah. Okay. Yeah. It does have scalability challenges. It does have sort of limitations on the kinds of programs it can run and where it can run. But if it works for you, like, you should totally use it. And people often say, they assume that, so my company Undo makes another time travel debugger for Linux, and people often say that surely RR is our competition. And it's like, yeah, yes and no, right? Not really, because RR is really good and it's free. And so if people can use it basically for their problem, they will. And it's when they can't that they come to us. RR and us have the same competition, printf. So yeah. So if you haven't tried RR, you just should, right? And if it doesn't work for you, then give me a call. And or if you didn't already, take a photo of that, enter the raffle, and 3 of you will win a year's license, floating license, so you can share it with your colleagues, of UDB. And you will have the power of time travel. That's it. Okay.
Maybe you can mention the --x command to GDB so that you can build your workflow. Yeah, you --x start, then break, then continue exactly the number of times the program will crash, and then you start reverse recording. And that's the only way to use the reverse.
Oh, the inbuilt GDB. Yes. Yeah. So, yeah, I'm trying to. There is another neat way, which is you can set an ignore number on breakpoints, and then so set the ignore break like 1 million, and then you can see how many times the breakpoint was hit.
Yeah, you do --s breakpoint and --x goes to
Yeah. So you mean like start? Yeah. Sorry. Yeah.
You build your
Like that.
the behavior of the program. It's really useful for big problems.
Yeah. And then you can build up that and just keep doing it and get more and more. Yeah. Yeah.
Just before it.
Yeah. Or so you can do that. That's a good technique. I haven't used that before, but I like that. The other way you can do it is there's some inbuilt scripting inside GDB, or you can use the Python. But that's, it depends on the problem space. But yeah, that's a nice technique. So I like that. Yeah. So then did that make sense? So yeah. So this, and then I can like do.
You can put as many checks command as you want.
Yeah.
So you build the life of your program. You break. You continue 20 times. Then you record. Then you blah blah blah.
Yeah. So you can do like that. You can just build up as much as you want. Yeah. Nice. I got that wrong somehow, but anyway, yeah, that's the principle. Any other big things that I forgot? I think there's pizza and beer, so we can continue the conversation.